Question is sum of perimeter of the circle as well as square. Circle will have the dimension r, then square, let the side of the square is equals to L. Sum of perimeters means perimeter of circle plus perimeter of square is constant, let the constant be equals to K. Perimeter of circle would be 2 pi r. Perimeter of square will be 4 into L equals to constant K. Let this be equation 1, which will give us the relation between two variables R and L. Prove that the sum of their area is least. Least word is used means sum of their area will become our function. When the side of the square is double the radius of the circle means we have to prove L equals to 2 times of R. Now sum of their area of circle as well as area of square is pi r square plus area of square will be L square. Okay. Instead of L, now we can substitute from equation 1. It is K minus 2 pi r whole upon 4 whole square. Let this be our function. So f of r is equals to 12. Next step, we'll find f dash r. Single differentiation, single derivative. F dash r is equals to 2 pi into r plus 1 by 16 will be constant. 2 into k minus 2 pi r into minus 2 pi. Let this f dash r is equals to 0. Therefore, 2 pi r is equals to 2 by 16 means 1 by 8. Again, 2 fours are. So we can say pi by 4 into k minus 2 pi r. We have to find the value of r, so we will isolate r. So first we have to expand the bracket in RHS. So we can say it is k pi by 4 minus of pi square by 2 into r is equals to 2 pi r. One of the pi will get cancelled out. Now we can say 2 into r plus pi by 2 into r is equals to k by 4. Taking the LCM, we can say pi plus 4 into r upon 4 or upon 2 is equal to k by 2 to the. So finally we can get the value of r is k upon 2 into pi plus 4. Let the single derivative be our equation 2 and this value be equation 3. So the double differentiation of this will be f double dash of r is equals to 2 pi r. 2 pi will be constant, differentiation of r is 1 minus of 2 pi by 4 or we can say minus pi by 2 will be constant. Differentiation of k is 0. Differentiation of minus 2 pi r is minus 2 pi. Minus minus becomes plus. Both the terms are positive and constant. So this is greater than 0. So we can say function will achieve minimum value at variable r is equals to k upon 2 into pi plus 4. So now from equation 1 and 3, pi r as it is plus 4l as it is equals to, instead of a from equation 3, we can say 2 into pi plus 4 into r. Expanding the brackets, LHS would remain as it is. In the RHS, we can say it is 2 pi r plus 8r. Okay, 2 pi r will be cancelled out from both sides. 4l becomes equals to 8r. Dividing by 4 both the sides, we can say l will be equals to 2 times of r. Hence, a proved window is in the form of a rectangle surmounted by semicircular opening. Total perimeter of the window is 10 meter, which means perimeter is constant. Let the radius of the semicircular opening is equals to x. Therefore, diameter will be equals to 2x. Hence, the length of one of the side of the rectangle will be equals to 2x. Let the other side of the rectangular be y. So the perimeter of the window will be equals to perimeter of semicircle as well as perimeter of three sides of the rectangle. Perimeter of the semicircle will be pi into x plus 2x will come only once, so 2x plus y will come twice, so 2y. This value is equals to 10. So we can say pi plus 2 common into x plus 2y must be equals to 10. Let this be equation 1. Now we'll create a function. What should be the function? To find the dimension of the window to admit maximum light through the whole opening. So area of the window will become our function. So area of the window will be equals to area of semicircle, which is pi into r square, or we can say here radius is x, so pi into x square divided by 2 plus area of the rectangle will be length into breadth. So length is 2 into x into breadth is y. So we'll substitute y in terms of x. Instead of y, we can write 10 minus pi plus 2 into x whole by 2. Yes, 2 can be cancelled out. We can expand this and we can write pi into x square by 2 plus 10 into x minus pi into x minus 2 into x, pi into x square minus 2 into x square. Okay. Now we have three terms related to x square. So we'll simplify that. Pi by 2 minus pi minus 2 into x square plus 10x. જેટલું બને એટલું સિમ્પ્લિફાય કરી લો. તો pi by 2 minus pi એટલે minus pi by 2 થઈ જાય. Minus 2 भी है. So now we can write this is equals to 10 into x minus of pi by 2 plus 2 થઈ જાય ને, minus sign બહાર લઈ લો તો. So it will become pi by 2 plus 2, or you can say pi plus 4 by 2 into x square. Let f of x be equals to our area. Then next step, we'll find f dash of x, which is equals to differentiation will be 10 constant. Differentiation of x is 1 minus pi plus 4 by 2 will be constant. Differentiation of x square will be 2x. Again, 2 gets cancelled out. Next step should be, let this be our equation 2. Next step should be, let f dash x is equals to 0. Therefore, we can say 10 is equals to pi plus 4 into x. Therefore, x is nothing but equals to 10 upon pi plus 4. So we have got the value of x. Let this be equation 3. F double dash of x, differentiation of 10 will be 0. We are differentiating second equation. So differentiation of 10 is 0. Differentiation of x is 1 into minus of pi plus 4. Constant term and negative, so less than 0. So we can say the value f of x, which is nothing but area, will be maximum when x is equals to 10 upon pi plus 4. So now we can say from equation 1 and 3, instead of substituting the value of x, we'll substitute the value of 10. That will be more convenient. Pi plus 2 into x plus 2y. Always substitute the constant value. Here perimeter is 10, which is constant. So instead of 10, we can write pi plus 4 into x. Okay. Expand the bracket both the sides. Pi into x plus 2 into x plus 2 into y is equals to pi into x plus 4 into x. Pi x cancel out. Then we can say 2 into y is equals to 2x will go to us RHS, 4x minus 2x will become 2 into x. So finally 2y is equals to 2x or y is equals to x, which is equals to nothing but 10 upon pi plus 4. Thus the dimensions of the window are 10 upon pi plus 4. Point on the hypotenuse on the right angle triangle is at a distance A and B. So A and B both are constant from the sides of the triangle. So from one of the side, the distance is equals to A. From another side, the distance is equals to B. So one of the value is A, another value is B. Question is, show that the minimum length, minimum word is used, means length will become our function. We have to find the length of the hypotenuse. Triangle ABC is a right angle triangle. Then we have another values M and N. So triangle PNC and triangle AMP are also right angle triangle. Triangle AMP and triangle PNC. We'll take this angle as theta, which means this will be also corresponding angle and equals to theta. In triangle AMP, see the total length of the hypotenuse is combination of two, AP as well as PC. AP we can find from triangle AMP. It is the hypotenuse of triangle AMP. We know the adjacent side, that is A. We know the angle theta, then AP will be equals to, we'll take cos theta. So cos of theta is equals to adjacent side, that is A upon AP. AP will get A upon cos theta. So one of the value we got is A upon cos theta. Okay. Next, PC. PC is the hypotenuse of triangle PNC. Here we'll take equals to sine theta, which is nothing but opposite, that is PN, or we can say directly B upon PC. So we can say PC is equals to B upon sine theta. So now we can substitute, instead of PC, B upon sine theta. Okay. So equation 1 and 2 gives us the value of AP and PC. This we can write as 1 upon cos will become sec. So A sec theta plus B cosec theta. And this becomes our function. let f of theta, our variable is theta, is equals to a sec plus b cosec, which is length of hypotenuse. Next step, we'll find f dash of theta, which is equals to a constant differentiation of sec is sec theta into tan theta, differentiation of cosec, b constant, differentiation of cosec is minus cosec into cot. Next, let f dash theta is equals to 0. Therefore, a sec into tan is equals to b cosec into cot. Therefore, we can say a upon b, all the theta related terms towards RHS, and we'll get cosec cot upon sec tan. So total value will become cos cube theta upon sin cube theta is equal to a by b, or we can say tan cube theta is equal to b by a. Let this be equation 3, or equation 4. We'll take single differentiation as equation 3. This is equation 4, and therefore we can say theta is nothing but equals to tan inverse of a raised to b raised to 1 by 3 upon a raised to 1 by 3. F double dash of theta will be a sec theta constant, differentiation of tan is sec square plus a tan constant, differentiation of sec is sec into tan. Tan comes twice, so we can say it is tan square theta into sec theta. This completes the differentiation of our first term. Now second term, minus b cosec constant, differentiation of cot is minus cosec square, so this becomes cosec cube and plus minus b cot constant, differentiation of cosec is minus cosec into cot. Again minus minus will become plus, cot comes twice, so cot square into cosec cube. Only cosec theta. Okay. All the terms are positive, value of tan theta is positive, so we can say this is greater than 0. Therefore, f of theta is minimum at theta equals to tan inverse of a b upon a raised to 1 by 3. Now we'll create a new triangle with angle theta. Tan theta equals to b raised to 1 by 3 upon a raised to 1 by 3. So opposite side should be b raised to 1 by 3, and the adjacent side should be a raised to 1 by 3. So according to Pythagoras theorem, the hypotenuse would become equals to under root of b raised to 2 by 3 plus a raised to 2 by 3. Now, length of the hypotenuse is equals to a sec plus b cosec. Okay. Now from the triangle we will take the values of sec and cosec. Sec will be hypotenuse upon adjacent. So a into hypotenuse would be a raised to 2 by 3 plus b raised to 2 by 3 whole raised to 1 by 2. This is our hypotenuse. Upon adjacent is a raised to 1 by 3. Solving this term, a raised to 1 upon a raised to 1 by 3 will become a raised to 2 by 3. while the multiplication will remain as it is. This completes a sec theta. Similarly, B constant cosec theta from the triangle will get hypotenuse upon opposite. So A raised to 2 by 3 plus B raised to 2 by 3 raised to 1 by 2 upon B raised to 1 by 3. B raised to 1 upon B raised to 1 by 3 will become B raised to 2 by 3. Inside the bracket, A raised to 2 by 3 plus B raised to 2 by 3 whole raised to 1 by 3. From both the terms, we can take this term A raised to 2 by 3 plus B raised to 2 by 3 raised to 1 by 2 common. So A raised to 2 by 3 plus B raised to 2 by 3 whole raised to 1 by 2 common. Inside the bracket, we will get A raised to 2 by 3 plus B raised to 2 by 3, which is same as the earlier term. The power is 1. Since both are in multiplication, the total power will become 1 plus 1 by 2, that is 3 by 2. 3 by 2. So A raised to 2 by 3 plus B raised to 2 by 3 raised to 3 by 2 is our length, which is our final value. So that the altitude means height of the right circular cone of maximum volume. Word maximum is used, which means volume will become our function. Inscribed in a sphere of radius r, so this radius r will be constant. So radius of the sphere is constant. Let the dimensions of the cone be capital R and the height of the cone be equals to h. This value is also equals to r. 90 degree. Let this portion be equals to x. So from the geometry we can say small r square is equals to capital R square plus x square, and the height of the cone h it becomes equals to small r plus x. So we have converted both capital R and h in terms of x. Let this be equation 1. Volume of the cone is maximum, so volume will become our function. Volume of the cone is pi by 3 into r square into h. Instead of r square, we can substitute small r square minus x square. Instead of h, we can substitute r plus x. Okay, we can expand the bracket and we'll get r cube minus or plus r square into x minus r into x square minus x cube. Same sum. Let f of x is equals to our v. Next step, therefore f dash of x તમારે રિવિઝન થઈ જશે યા સમ કરેલો જ છે. Pi by 3 since r is constant, differentiation of r cube will be 0 plus r square constant, differentiation of x is 1 minus r constant, differentiation of x square will be 2x. So 2r into x will get, for the last term we'll get 3x square. Next step, let f dash x is equals to 0. Therefore, we can say 3x square minus 2rx plus r square plus 2rx minus r square is equals to 0. Therefore, factors will be 3x minus r into r plus x equals to 0. Therefore, x can take value equals to r by 3 because it is a dimension and cannot take the negative values. So r is equals to, sorry, x is equals to r by 3. F dash x will be our equation 2. This value will be equation 3. Next, double differentiation of x. will be equals to, again pi by 3 constant inside the bracket, differentiation of r square will be 0 minus 2r, differentiation of x is 1 minus 6 into x. X is positive but the terms are negative, so over value will be less than 0, therefore f of x will be maximum. X is equals to r by 3. Now altitude h is equals to r plus x. Instead of x, now we can substitute r by 3. R plus r by 3 becomes 4r by 3 equals to h, which proves the height of the cylinder of maximum volume. Word maximum is used, so volume will become our function that can be inscribed in a sphere of radius r. So radius r is constant. We have to prove the height is equals to 2r by root 3. Also find the maximum value volume. So we have to find the value of the volume. First, cylinder inscribed in a sphere. Let the dimension, radius of the base of the cylinder is r. This portion from the center of the cylinder to the base is x, which will give us the height of the cylinder becomes equals to 2x. To derive the relation between r and x, we can say from right angle triangle, r square is equals to capital R square minus x square. This will give us the relation between small r and x. So let this be equation 1. Now, volume of the cylinder is maximum, so V is equals to pi into r square into h. Instead of r square, we can substitute pi into capital R square minus x square. Instead of h, we can substitute 2x. We'll expand the bracket, so we get pi 2 pi r square into x minus pi into x cube. Let this v be our f of x. 2 pi x cube, not pi x cube, 2 pi x cube. Okay, let this volume be our f of x. Next step would be f dash of x. હવે સમ સિમ્પલ છે, આમાં ખાલી સિરિયલમાં જ મેઇન મહેનત છે. હવે બધું સિમ્પલ. 2 pi r square will become constant. Differentiation of x will be 1 minus 2 pi constant. Differentiation of x cube is 3x square, which will give us 6 pi into x square. Let this be equation 2. Next step, let f dash x is equals to 0. So we can say 2 pi r square equals to 6 pi into x square. Pi will get cancelled out, 2 3s are, so we can say r square equals to 3 into x square. Or we can say x is nothing but equals to r by root 3. Let this be equation 3. Next step, double differentiation. So f double dash of x will be equals to 2 pi r square is constant, so differentiation 0, minus differentiation of x square is 2x, so minus 12 pi into x. X is positive, overall term will become negative. So we can say this f of x is maximum at x is equals to r by root 3. Now height h from the figure we can say it is equals to 2 times of x. So that is equals to 2 times of r by root 3. So height is equals to 2r by root 3. This proves our one of the equation. Okay, equation number 4. Write v equals to pi into r square minus the value of x is r by root 3. So x square would be r square by 3 into 2x, that is 2r by root 3. So we'll get pi into 2r square by 3 into 2r by root 3. 4 pi upon 3 root 3 r cube will become our volume. So that the height of the cylinder of greatest volume. What greatest is used, volume will become our function. Inscribed in right circular cone of height h. So height h is given and alpha is also given. Both are constant. So again, height of the cylinder of greatest volume is one third that of the cone. So we have to prove volume of the cylinder is 1 by 3 the volume of height of the cylinder is 1 by 3 the height of cone. And the volume of cylinder is 4 by 27 pi h cube 10 square alpha. Total height h is given. So this value is equals to h, which is constant. This angle, semi-vertical angle, is also constant and equals to alpha. We'll assume the dimensions of the cylinder. Okay, radius of cylinder is r and the uppermost value is x. Now we can convert the height h of the cylinder and the radius of the cylinder in terms of x. From the right angle triangle, we can say tan alpha equals to, alpha is constant, tan alpha equals to r upon x. Let this be equation 1. This gives us the relation between r and x. The height of the cylinder h will be equals to small h minus the value of x. Let this be equation 2. So both the dimensions of the cylinder r and h are converted in terms of single variable, that is x. Greatest volume means volume will become our function. Volume of the cylinder is pi into r square into h. We'll substitute the values. Pi constant, instead of r square we can write 10 square alpha into x square into, instead of h we can write small h minus x. Again expanding the bracket we can say pi h 10 square alpha into x square minus pi 10 square alpha into x cube. Let f of x be our v. Next step, f dash of x is equals to pi h 10 square alpha is constant. Differentiation of x square is nothing but equals to 2x. Similarly, minus pi 10 square alpha is constant. Differentiation of x cube is nothing but 3x square. So now we can say it is 2 pi h 10 square alpha into x minus 3 pi 10 square alpha into x square. Let this be equation 3. Now we'll assume let this f dash of x is equals to 0. Therefore we can say 2 pi h 10 square alpha into x is equals to 3 pi 10 square alpha into x square. One of the x gets cancelled out, 10 square alpha gets cancelled out, pi will get cancelled out, and directly we will get the value x is equals to 2h by 3. Let this be equation 4. Next step, double differentiation. So f double dash of x is equals to, we'll differentiate equation 3 where 2 pi times h 10 square alpha is constant. Differentiation of x is 1 minus 2 into 3 becomes 6 pi 10 square alpha into x. We'll substitute x is equals to 2h by 3 and we'll get 2 pi h 10 square alpha minus 6 pi 10 square alpha, 6 pi 10 square alpha into, instead of x we can substitute 2h by 3. 3 2s are, so 2 into 2 4, 2 pi x tan square minus 4 pi x tan square. Overall value will become negative less than 0. So f of x, which is nothing but volume of the cylinder, is maximum at x is equals to 2h by 3. Now the height of the cylinder h is equals to small h minus value of h which is 2h upon 3. Taking the LCM, this becomes equals to h by 3. So this proves our first part, that is height of cylinder is one third that of the cone. So V equals to, from the second equation we can say pi tan square alpha into x square. Instead of x square we'll write 2h by 3 whole square, that is 4h square by 9, minus pi tan square alpha, sorry, multiplication of h minus value of x is 2h by 3. Substitute the values and now we'll get 4 pi tan square alpha by 9 into h square into h minus 2h by 3 becomes h by 3. So 4 pi tan square alpha into h cube will become our numerator. In the denominator 9 is a 27.